All right. I think we're live. Let's see. Can I see chat? How do I see chat? Oh, there we go. All right. Okay. Wait for people to roll in first. All right, the first thing I want to look into is going to be this autofocus stuff, because I think that's going to be either pretty simple or a bit of a dead end. So it's also a little bit boring. So until people show up, that will be what we do. All right, so actually, you know what I'll do? Let's get chat up in here. So we have that. Or how are we doing print? Oh, if stir buff. Stir print of. It's probably under print, right? Stir print. Huh. I thought we had. Right. Stir print. Hello, hello. One sec. All right, kids just came home. So what we're gonna do is figure out how to make this window not actually respond when it's not in focus. Because people are complaining the calculator's burning battery. Hello, hello. So we gotta figure out is how is it that SDL handles window focus, and how do we just like pause the app while that's running? If there's like background noise, by the way, a bunch of kids just came home. So right now we have this SDL app iterate stuff going on. And the app is going to continue running like no matter what's happening. That's what's burning the battery. So I presumably, okay, so this one is saying, let's print that out and make sure this is true. We're just sleeping for 10 microseconds if it's minimized. That's weird. I see, so it's just sleeping. So we probably need to do the same thing if window is not in focus. So I have this counter, which is telling me like whether the thing is running. So let's see, it's like 4, 3, 2 or whatever, 4, 4, 3, 7, 8, 4. Okay, so if we open it like, so if it still says like 4, 4, then it's been sleeping. Okay, so it's been sleeping. Okay, so that's working. So when it's minimized, it's not doing anything. Hello, hello. Greetings to you as well. So I wonder if, can we do like window flags? What's window flags? Still window flags. No flags. Can actually, maybe we need to, can we just do minimize? Is there a focus? Is there a window? Input focus and mount? What's the difference? Input focus. Let's try that. So if it's, oh wait, or, this is annoying. We need like not input focus. Okay, I don't want to make the logic complicated, so let's do the thing that I was doing. So we're trying to make the window not update when the app's not in focus because it's burning people's batteries out. So if it's minimized, sleep, or if not, SDO window focus. Is that right? In focus? Input focus? That's what it was. Okay, so that means if we move the window out of focus, it should stop updating. So let's see. Okay, so we're in focus. Let's pin it. Okay, so now it's pinned. Okay, now it's out of focus. It's no longer doing its thing. Okay, that's good, right? I think that's good. Then when we go back, it's right back at it within a frame. We could probably make it sleep for longer. Right? Let's see. Is it noticeable? It's not noticeable. So sleeping for 100 milliseconds is better than sleeping for 10 milliseconds. So that seems pretty safe. And it's, let's see, can I like paste as quickly as I can in there? Yeah, so if I click on the window, yeah, it's really fast. Yeah, okay. So I was just thinking, should we sleep for less? But I can't notice any difference. So that was easy. So this is our wish list for the day. Don't run when out of focus. Completed. And then someone in Discord, Viking, had an idea for investigating dead input and also reported this bug, which is right now, if we type 56 minus 3, that makes sense. Times 4 makes sense, it's 44. That makes sense, still just says 44. But if you do this, you get 4, which is really bizarre. Because why is that happening? So that's going to be the fun bug for today. Have some tea. How's the audio, by the way? Does everything sound all right? Check this in. Oh, I gotta remove this mess. Thank you. So I'm gonna keep this code just because we may need to test this later if the bug persists, but probably not. If people have other bugs they want to report or just questions, just let me know. I'm just going to try to fix some of this stuff and take care of what people have been asking for. But if there's other things you want to talk about, calculator related or not, I can try and do it in parallel. Okay. So, fix running out of focus. Actually, I'm actually curious, what is the difference between mouse focus and input focus? So, input focus. Is there like a description of this somewhere? Because maybe we need to be also dealing with mouse focus. Is that true? Keyboard grabbed? Do we only care if it's... What's mouse capture? Unrelated to mouse grabbed. Windows grab mouse input. Okay. Let's see. Google. Okay. What is the difference between... Should we do AI mode? Maybe. Input focus. Mouse focus. Mouse capture. And keyboard grabbed, I guess. Let's see. Windows active and receiving keyboard input. Only one window in the system can generally have this at this time. Okay, input focus is like the big one. Mouse focus, the mouse pointer is currently hovering over the window regardless of whether it's active. Okay, so we don't want that, I think. I hope you're right, Gemini. Grab flags. Streaming regular, I'd like to, but just due to like work and other personal projects and family stuff, it's like really hard to find a reliable time. But maybe. I don't really have like content prepped or anything, but whenever I get a chance to work on the calculator, I try to stream it because it's kind of like usually has some interesting programming bits and has value to people. Mouse grabbed. The mouse pointer is trapped inside the window's boundaries. It cannot leave the window. That sounds dire. This is typically used for FPS games. Glad you enjoyed the Woocast streams. Those are cool, and those are like way more curated and interesting. Being frank, this is like basically raw programming because some people wanted to see how the calculator works, and I figured I would just stream it whenever I'm working on it and see if people have input or questions. So it's going to be lower key. By the way, those are actual crickets in the background because I have like geckos. So those are feeder crickets. Window keyboard grab. The keyboard input is restricted to this window. It prevents other applications from receiving system level hotkeys. Interesting. Okay. When does mouse capture? The window received all mouse events, even if the mouse pointer moves outside the window's boundary. Unlike grabbing, the cursor is not restricted, but it can move across the screen, but your application receives the coordinates. Okay, so sounds, and it's used for handling scenarios of dragging. Starts inside the windows, move up. Right, okay, so like grabbing stuff from in the window and then taking it to another window maybe. Okay, so it sounds like input focus is like the whole, the main one. I suppose I can make it, well, you want it to keep rendering. Yeah, you want to be able to render. I was gonna say maybe we should look for mouse focus also, but I don't think so because oftentimes you're typing in the calculator, but your mouse is outside, so there's not really any advantage, I think. I suppose, and rendering whenever mouse is in the window, but the keyboard is not in focus. Would not help us any because it's like you're just hovering over the calculator. Why would you want it to be updated? Hello, welcome to the stream. Okay, so I think that's good. I think that's all we need. So that one's checked off. So that should save people's batteries who are just like leaving the calculator in the background on a laptop, myself included. Okay, now is this guy. Okay, so here's what we got for today. This is gonna be the main thing, and I'm gonna go into final mode. Out of final mode so we could see the true. Been falling asleep to him for a little while. Woocast streams are great, but they can be very dense, which is good, but I guess also good for sleeping. Okay, so the problem is this code. So let's see. So this is our parser output. Okay, so we get subtraction 56 minus, multiplication 3, sub-expression 4. Okay, so that's the actual parse. So what happens when you do this? Subtraction 3, sub-expression number 4. So what? Oh, so the result is just 4. So it's the same as this. The parse is putting a semicolon between them. Interesting. Why would that be? This is going to be an interesting bug. So that is used for things like, I think, AB. So if you have like A is 5, B is 3, if you type A, comma B, then the result is 5. Oh, I can see, I can't see it here. This is like my debug harness. The output is 5, 3. You can see output here, 5, 3. This generates my test cases. So I can just like type something in, and then I have this test, and this is my test format, and I put it into my tests folder, and then that becomes the test. And these are all the tests that are currently running. I just run them every frame, lol. So as I live code stuff, if I change anything, I see my tests break because they're just running all the time. At some point, this will probably become impractical. Anyway, so if you type A comma B, you get both. But if you type A B, that's parsed as a semicolon. I don't remember why that is, but it has a reason. It's the reason. Yeah, how's that for testing, Big Tony? That's some big tests right there. People say I don't test. I test every frame. Come on, bro. Do you even test? Every keystroke. I don't know why I'm parsing this as a semicolon, but there's got to be a reason. A bunch of maybe one of these tests would tell us. Maybe if I break it, the tests will tell us why I've been doing it this way. But anyway, sounds like, I mean, this is kind of sensible. I kind of understand this because it's basically the same as this. And the calculator basically says, well, if you just have two symbols, that's not a valid parse. I don't want to parse it as a comma. I don't want to parse it as a multiply. So I might as well parse it as a semicolon rather than issue an error. So it's the same as if you put them on different lines. But it's getting confused with this, which ought to be parsed as a multiply. Because if you do 2a, that's going to be parsed as a multiply. Is that good? What's x, y? So why is a, b parsed? Like, wouldn't x, y be parsed as a multiply? Because x, y can't be because they fuse. But why isn't x, y parsed as a multiply in general? Should it be? So 5, 1 is parsed as an, what does that parse as? It just throws away 1. So 5.5 gets parsed as 1/2. So this is an implied plus. And so number, you wouldn't expect it to multiply if there's a space in between. Yeah. I don't kind of either. But 5x wants to multiply. So why doesn't 5x multiply? It's kind of feels, if I write f of x, 5x, like that's pretty readable. That feels like it ought to multiply. And if I write 5xy, if I type yx, I'd parse that as a multiply, right? In the context of math. Because I can't write xy. Obviously that's a thing, but then like this is also a thing, but that doesn't mean anything in the calculator right now because you know, only the last statement is returned. But if you did like something like this and these were functions, then it would be 2 statements, and if they had side effects, then that would matter. But currently the language doesn't have, well, yeah, you can have side effects. Yeah, you can currently have side effects because you have access to the global scope. Okay, but in any case, feels like this is definitely broken. This, oh, I guess that's what's happening, right? Because it's a number. It almost looks like it's going to be a call, right? Because if this was like this, that's a function call. Weird. That's wild. Calculators are crazy, man. They are crazy. You think like, oh, just make a calculator, they said. It's a good thing I have leftover donuts. All right. So is this just invalid? What's everyone think? Should this actually compile and be the same as 3 times? Get sugared up. I made like not sweet tea because I was like, oh, okay, I've had enough sweet tea today. And then as soon as I start drinking non-sweet tea, I'm like, oh, what's something sweet with my tea? I feel like this should multiply. But it's so weird if that multiplies, but 56 minus x 4 is a function call, right? Isn't that weird? Like if I had this, right? If I have this, everyone's like, yeah, it makes sense. I guess that's a multiply. But here it's like, x is not a function. Unless I want to do type inference and be like, x is a variable, therefore. God. That's gross. So one plan I have is for the evaluator to substitute everything. So that like part of the evaluation step is going to be essentially like a compile time evaluation, which means as part of the so like I want to have a simplification step, so which sort of like simplifies sub-expressions and just generally large expressions, because that's useful sometimes. Sometimes I have a big expression, I just want it simplified, so I want to just punch it in the calculator and get the simplified version out. I use Wolfram Alpha for that right now. And I want this to do it eventually. And so part of that would be running essentially like a substitution pass. And so like for this lower piece of code, right, I would expect 3 to get substituted in, and effectively during some substitution steps, you'll get into this version, and then it would just carry out the multiply. Versus if it evaluated as a function, then it wouldn't substitute, it would call the function. So that implies that the parser actually can't know whether it's an implicit multiply or an implicit or a function call until it knows the type, and it doesn't know the type until it's, well, it does know the type. Okay. Yeah, I didn't notice that ambiguity either in math, by the way. But yeah, there's conventions of FG. What if the function has to be uppercase? Then it's easy to see. Yeah, that's true. I'm trying to stay away from forcing any kind of case, actually, because unlike sort of a real programming language, I want people to kind of just, I want this, I'm imagining people write very short programs with this, and I imagine them wanting to learn as little as possible about the language. That's why the notation is like hyper minimal, even at the cost of like features. Although I'm not sure any features are totally sacrificed right now, but like maybe at the cost of familiarity, I would say. So for example, constants right now are case insensitive in general. So you could type pi, you could type pi, you could type pi. So whenever you look built up constants up, it just like allows you to use all 3. So if somebody wants to be sort of C style, if they want to be lowercase, or if they want to do that, that's all fine. And it'll also take the Unicode pi as well. So that's kind of the idea. And so my hope is that symbols are just like user's choice. Whatever they want to use, whatever convention they want to use just works. Because it should be their calculator. But yeah, I think the parse has to be type aware. So the way the parser currently works is that it outputs an AST, as one would expect, but it's like very abstract. So the parser doesn't even actually know that it's a function call. So for example, like these are the things that come out of the AST, the AST node types. There's like symbol, the operators, addition, subtraction, etc., the built-in operators. And in fact, maybe these should just be like abstract node operator and then have a sub thing of what they are. Because right now it's like, I don't know. Maybe it doesn't matter. So there's sub expression, which are like the parentheses. There's range, which are square brackets, but I don't do anything with them yet. There's definition, which is either a variable definition like x colon 3 or a function definition like x colon x times x squared. So both of these are considered definition nodes. And then there are statements, which is anything that's part of a function body or just the implicit main function that all of the upper code is running in. So if you had something like this, then that would be 3 statements inside. So you could see them. So there's a statement list. So there's actually not a statement. There's just a statement list because statements are whatever. And then expression list is like what goes inside the function. And so that might be argument definitions or the calling or the parameters for the function definition or arguments for the actual call site. I found it to be useful to parse some abstract thing. I guess, yeah, that's what I'm doing. So yeah, you could see the parse is fairly abstract. Yeah, like you see stuff like definition, symbol, number. So like, for example, if you look at function, so f of x, x squared, x times 2 versus v equals 45, right? So for a definition of a variable, you're going to have definition, symbol, number, and those are the children. And for a definition of a function, you have definition, symbol, and the symbol has a child expression list, and then the second child of the definition is a statement list. And so then when the evaluation happens, it looks at a definition and says, hey, okay, do we have a symbol? We ought to. If we do, does the symbol have a kid? If the symbol has a kid, then that's a function definition. If the symbol doesn't have any kids, that's a variable definition. And that's how it figures it out. And then if you have a function definition, there better be a statement list. And so there's like a bunch of checking around that. So that's how it works now. And so in this case, if we have this sort of ambiguity where we're saying v of 3 here, we error out not a function v. So we actually, yay, bravo, we error properly because it's saying we're going to have to call v. But if it knew that v was not a function, it could multiply. And so here we have, here you have like v expressionless number, but then it's like, this is a function call. So anytime you have a symbol statement who has an expression list as a kid, that's a function call. But in this case, that's a multiply. Okay. Like A and B, B, then you have like, yeah, exactly. Yeah, so it's basically like what you're saying. You have a couple of cases to check. And then the nice thing about it is if your parse ever looks ambiguous when you're deciding what it means, well, then the parsing is ambiguous, I think. So far that's been really nice because it lets me easily notice when there's ambiguities in the syntax because it's just a recursive descent parser. And so when I write the code, it's like very clear if there's no difference in the structure of the tree, then there's nothing I can do to tell them apart. And the structure of the tree is is the syntax, I think, is a good way of saying it. So that's kind of nice. Is currying out of scope? Could you elaborate on how currying would help here? I'm just curious. I didn't pay much attention to it. If you need to separate functions from values using. Yeah, so equals. Right. So yes, I could disambiguate it, but it kind of goes against the philosophy of the language that I shouldn't take the easy way out and make it nice. Okay, but just like a meta comment about the calculator project is this is like my effectively exercise gym, because I want the calculator, but usually I mostly use it for like programming practice, so that it's a place where I deliberately try to do the hard thing, not for no reason. So like it should still have a reason because I want to be grounded in some kind of reason, but I'm not driven by any kind of like pressure to ship things, and so I sort of am like maximum stubbornness mode. So I want it to be a colon and the same in both cases. So if it means that like I have to spend 3 days doing that, that's what this is about. So that is maybe bad marketing for the actual application, but that's where we're at. But for equals, I actually have a cool idea for equals, which is living in my brain rent-free, which is why I'm saving it. And partially it's this thing of like, I don't want to, like, I think it's weird to type if x equals 3. Like obviously for programmers, it's fine, but it's strange. I think that's why a lot of languages have like switched over to this kind of assign syntax. But what I want to use it for is I want to be able to write something like f of what equals, or sorry, like f of 3 equals whatever, and have those things be compared. So like, I'm not saying that. Let me try to say it again. Okay, so let's say I want to find the root, like where the zero crossing is of x cubed, right? So the traditional language, like mathematic or something, you're gonna do something like find roots f on the range of -1 to 1 or something, and then it will try to find your root, and it'll sort of probably print out 0, right? What I want to do is I want to just type f of what equals 0. So I want to do that. And so this like question mark plus the equals feels really elegant to me, and I want to see it in the world. And then I could just be like, f of what is 3, f of what is 2, and then just play with it like this, because a lot of what I do is I just mess with the calculator and see what the results I get. But yeah, I want to be able to type that and have a solver in the back run and figure it out. Obviously, this isn't maybe ideal, because if you have like very careful root finding, you may want to give it a range. So I want syntax for ranging as well, maybe, but I just somehow want to make this happen. The other thing I want to have happen is like 100 feet equals how many inches. I want that kind of thing. So I want equality to be this like magical figure out the equality operator. And also I want it to work as a Boolean. So if you do like v equals 45, I want that to be true. And if you say v equals 3, then I want that to be false. But the kind of crazy idea that I can't quite understand, but I think it's very Lispy since we're talking about Lisp stuff, is I actually want v equals 45 to return probably 45. Or like the truthy part, whatever that means. And then this to return like the not truthy part. But I don't quite, like this probably should return v not equals 3. And this one should literally just return itself. And then what that, so like when you look at conditionals like v equals, or if v equals 45, the if statement needs to just basically gets itself, the statement back. But if you just print it, then it prints to 45. I don't know. Maybe I'm trying to avoid true and false. For some reason, I'm trying to avoid true and false. I don't know why. I can't quite put my finger on it. Oops. The idea would be that using a function as a value variable, then the result would also be a function that lazily evaluates the inner function. I don't know if that makes sense, basically. Okay. I think it makes sense. Let me think about it. The idea would be using a function as a value variable, and the result would also be a function. And how does that solve the ambiguity? Because in this case, v is a variable. By the way, is the text readable? I'm kind of assuming the text is readable. I hope it is. Yeah, if this, yeah, I don't know how currying would help with that. I don't know. Maybe I don't get it. So then, yeah, so if there is such a simplification pass, I guess so I think, does currying work currently? I think currying may already work. Like I think functions are first class. Let me see. G, so you can have G, oh, but there's no closures. Like, so you can do stuff like this. You can do like f of x, g of z is 3 times z. And then you can call g of x, and then f of 1 is going to be 3. F of 2 is 6, right? So that works. So you can make functions inside functions. That's all gravy. And then you can also, I think, do this. If g is in global scope, that also works. So we have proper scoping so that when you go into f, you still have access to g. What I don't know if it works, can I return g? Oh, look, it returns a function. So can I do f of 2 of 3? Yes. No? Sub-expression 3. Yeah, so not quite. So it returns, oh yeah, look, it plots it. So it returns the function. It returns the function, but then you can't call the function because of this sub-expression stuff. Because it parses it as a sub-expression. Interesting. It's like one, I knew this was going to be, I had a hunch this is going to be a nasty one. It's like the more rope you can, rope you pull. Almost there. How is the function call working? Do you see a symbol node and then replace it with a definition and apply the arguments, or do you look ahead? So at the moment, there's 3 stages. The there's tokenize, obviously, and then that goes into parse, and then it goes into eval. And actually, tokenize and parse happen in one stage because the tokenizer it's just one look ahead, so there's not even like a stored list of tokens. And then so parse, makes an AST, and then that goes to eval diagrams. And so what eval does, broadly speaking, eval is a stack machine. And so whenever it encounters a definition, it adds it to the symbol table. And whenever it encounters a call, it looks up the symbol table, sees what the symbol resolves to, and then it pushes the body of the function onto the stack, like all the statements as part of the definition. And then the way function calls work essentially is like if you have f of x, before a call occurs, I push a stack frame onto the symbol table. The symbol table is basically a stack. And so when you call a function, you push an entry, you push the symbol table, and then you set the entry for x in the symbol table to be whatever the argument is, and that's what does the argument binding. And so when f of x runs, what it sees is effectively what it sees is a merged symbol table from everything that's above its scope plus its arguments. So it can't actually tell currently that x is an argument by the time you hit the statements inside a function. They look just like statements inside main, like it's just a statement list, and it just happens to be that x is bound as whatever the argument is, like in this case 2. So that's nice and elegant and simple so far. But when you see f of x, do you replace f with its definition and then call in when you eval a symbol, or do you wait until the function call? Replace f with its definition. By the function call, you mean the brace? Because what it sees when it sees f of 2, the abstract syntax tree at that point is symbol f. It has a child expression list, and that expression list contains the number 2. So in eval, I hit a symbol node. In fact, we can just do it to see if. So where is like, make it a little bigger for people. So here's like the run of the stack machine. And then we will, where's like, well, anyway, this is the actual meat of it, run advanced. This is what steps the functions. So if it's an eval type instruction, there it is. If the node type is symbol, here's what it says. If we have a kid and the kid type is expression list, then eval function call. Otherwise, it's an error. Symbol kid is not an expression list. So for example, if you attempted to somehow, it's actually an invalid AST tree. That's why it's an assert. And that's why it's a fault message, because it really ought not to be happening. That would be an invalid syntax tree. But if you don't have a kid, then it's an eval variable. So in practice, what that looks like is this. If you have z, whatever z equals 3, z, if you just see pure symbol, then it knows that it's a variable lookup. And if you see a symbol that has a child that's an expression list from the parse, it treats it as a function call. So it basically relies on the parser at the moment to know it relies on the parser at the moment to give it the right structure, and then it uses the structure to identify whether it's a function call or not. So if instead we had something like this, the parser at the moment says, oh, it's a symbol followed by a paren. That must be a function call. So I I treat it as an expression list, versus if it was a 3, I treat it as a sub-expression. And so the reason that's happening is because in the parser, which is like just a simple Pratt parser, statement chunk is kind of like the leaf token. So I call them, statements are like the full statement or an expression, and a chunk is like the leaf token. And so if I see a symbol, then I'm like, cool, add a symbol. And here's a good, oh, it's useful. So when we see a symbol within an expression, it will either be a variable lookup or a function call. So I'm assuming that we can tell by the parens coming after it. If we can't get arguments, it's a variable lookup. So, and adding nil args as a kid is a no-op. So whenever I parse a symbol, I immediately attempt to parse an argument list. And I'm already assuming if it follows a symbol right away, it must be an argument list. Whereas for all of this to work consistently, I would have to parse it as an expression list, which is what it makes. But if you see here, right now it's saying symbol Z expression list. It needs to be parsed as symbol Z and then expression list 3. So instead of like it being a child, it needs to be next to it. And then the evaluator needs to decide whether they belong together, or we're going to insert like implicit multiply if symbol is value. Good night, Big Tony. How does a function call work? If you have a stack-based VM, when you see a symbol, you would usually do the substitution right there. So the top of the stack would have a function pointer at the top, and then you see a function called expression, and pop the function off the top. Then you branch on whether it's a function or a number. Have a good sleep, Marshmallow. Yeah, full disclosure, Tasty Crayon, I've never written a compiler. I'm just kind of like freewheeling it. So with that context, I'm just kind of like learning as I go. So I think, having spoken to some other people, the way I wrote my VM is kind of funky. And so probably I need to rewrite the VM for a few reasons. For one, I'd like to do simplification. So I probably basically need a pass over the AST that happens before eval, which does simplification. And in this case, it would replace the Z with 3. Then everything would just work. But what you're saying also sounds like it could work, because the top of the stack would see a function pointer, and then when you see the function called expression, and pop the function off the top. So basically you're saying Z just goes on the stack, and then expression list comes up, and it's like, oh, what's on the top of the stack? Is there, like, what's on the top? Oh, it's a number. I'll do a multiply. Oh, it's a function. And then this expression list becomes arguments, right? So then it's kind of interesting because, like, Okay, so you can have two kinds of parentheses, right? So maybe one mistake I'm making is I'm too early. I'm making a distinction about the contents of the parentheses, both up front as how I parse them, and also like in post, because right now, when you type, f of 3, 4 or whatever, this gets parsed as expression list. 3, 4. But if I type f of 3 plus 4, that gets well, I mean, this actually is an error because expression, well, actually, no, sorry, it's incorrect. This gets parsed as expression list 3 plus 4, and then that flattens out to 7. Or rather, expression list add 3, 4, right? So, because you could type that, right? And so as soon as you hit a symbol followed by a paren, I'm like, that's a function, man. That's going to be a function. Versus I think what you're saying is like when I see f of 3, 4, I should parse it as symbol parentheses or something, right? And then that might have 3, 4. And so then these would be like your categories. So you would have expression, you would have things like 3 plus 4 times 8, whatever. List 3 comma 4 comma, sine of 3 times 4 times 3, whatever. That's a list. And then you could also have, I guess it would be a statement list if you had 3, 4, 8, sine of 3 kind of stuff. And then you could even have x3. And so maybe the parser should just parse out parentheses. And so what you'd see is, in a bunch of these cases, you'd see symbol followed by parentheses, and they would both look like statements. And then when it came time to evaluate them, it would be a case of like, you can't evaluate something right off the bat. You have to look at the next thing before you can decide how you're going to evaluate this thing, because the parentheses in some cases would be, in the case of like f, so in the case of a parse like f expression, you would parse that as f times expression. In the case of f, well, actually no, because so you'd have a bunch of different versions. So if you have f, which is like, we're assuming that's a function expression would be function of expression. Function of list is function of list, makes sense. Function of statement list is error. And then if you have a v expression, like a value, then that's v times expression. And if you have v list, that is bananas, so that's error. And v statement list is also an error. Yeah? And so for that to work, the stack machine needs to know the type of the symbol, and it needs to know the type of parenthesis. Right? So we want to do a pre-pass. So basically, we want to parse all the parentheses. So instead of doing this, so what I'm doing right now is whenever I hit a symbol, I automatically assume if there's parentheses following it, it's going to be a function called the end. So I'm basically assuming if it's a v, if it's yeah, if in fact it's always, we assume that it's always this. If there's a parentheses, if some kind of parentheses is occurring, I'm going to assume that it's, well, it's one of these two. But I currently don't support this one at all because if I see it, I don't know the symbol because I'm not doing the symbol lookup. I could do the symbol lookup inside the parser. So I used to actually do the symbol lookup. I used to do the eval like effectively as part of the parse, but obviously that's not a good idea. But I thought I could get away with it for the calculator. But I hit a problem with recursive functions because obviously they just go on forever. Well, if they go on forever because the person messed up the recursion, then they just go on forever, which means the whole calculator crashes. So I had to switch to a VM purely so I can maintain my own stack and then like basically detect stack overflow or like at some point just bail out and not crash the app. So that's why I did the VM. But as part of that, it meant the parser lost any notion of a symbol table. But because the calculator is just top to bottom evaluation, theoretically, if I kept a symbol table during the parse, I would even know at this point already whether the symbol was a function or not. Is that true? No, that's not quite true. And the reason that's not true is if I want to support something like currying, so g of f, return f, then inside the body of g, you don't know whether f, let's do like f of 3 or something like that. Here, you don't know if f is going to be, if we're going to call it g3, in which case f becomes a value, or you're going to call it g with sign, in which case f becomes a function. So you can't know during parse the types of things. So you have to parse. You have to parse the parentheses generically, which means they appear in your tree as siblings rather than children. And then a subsequent pass looks at neighbor siblings and says, hey, if it's a symbol followed by a parentheses, we ought to combine those in some way. And we can't combine them until eval. I suppose we could yeah, that's okay. So an interesting idea would be if you see something like this, to hoist it into something like, so like if you see f of 3 or what, f, yeah, just like f3. If you see that, parse it as, you see the symbol and you parse it as a, I don't know, like a pair, and you say symbol f parens 3. And you parse it as a pair, and then a later pass or during eval, you simply say, okay, we got this pair. It refers to a symbol, and to to convert the pair to either a lookup or a call, we need to know how it's being bound. And that way, rather than like not having a pair, like if you don't have a pair, like, if you just have something like 3, 5 plus f of 3, that would parse as like add 5 symbol f 3, which is really weird. They would just be, it would look like you'd then have to write this simplifier, which like looks ahead. Oh, sorry, this would be parens and then 3. So you'd have to write something that walks this tree, and then it's like, oh, if I have a symbol and the next thing is parens, do some stuff. But we know that we're gonna have to replace it with something always. Like it's never gonna be a case of statement list. Is that true? Because now I'm trying to remember, why the hell do I parse this as a statement list? Because otherwise this should also be a statement list, but that's weird. Like if I type this, it should clearly evaluate as sine of 3, right? So I think the pair is the right approach. And I think whatever I was cooking with this is just AB is just not that useful. Because I think what I was cooking is that you could type like f of x and then b. So like imagine you type something like compute my values and then just print b. And I wanted that to be equivalent to this because I'm into single line statements. But the line break is probably important here. I think you want the line break because it otherwise is very, very ambiguous in many other cases. Because like if this works as statements, as 2 statements, that implies, well, it's a little bit different because this is a function call. So this kind of at least makes sense. Like it would be weird if you just say like, there's never a reason to say like my value and then b, because my value just returns the value and then it has no side effects. Interesting. So, that's nasty. So I kind of want this still. I still want compute my values and then b to be parsed as a statement, because I can't see a reason why it would ever be anything else. I guess unless it's it returns a function. God damn. Well, it's cool I'm streaming this because now this is all on the record and I can look it up when I get totally confused next time. Okay. I like the pair. I would also say you would want to leave undefined symbols alone in the output. So if you have something like, yeah, absolutely. I want to do that. I really, 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 really want to do that. Because that is also what I need to do for simplification. So for example, I want it to be the case that if I type, a squared plus 3a squared, a squared, that the output would actually be 4a squared. Like I want it to do that. But then I want it to do much more than that because I want it to be like, if you do this, a cubed, I actually want it to do that. Because I want to do symbolic manipulation. So that requires leaving a alone because, yeah, like I don't even care what a is. I want pronumerals, I guess they're called. So we want pairs, huh? How bad would that be? Okay, so I already have left paren. Left paren already exists, and it creates a type subexpression. Should we just try it? Should we try it, chat? It's gonna break everything, but it could be kind of cool. Let's just try it. So we're gonna have a new thing, call it pair. AST node type. Pair. Pair. Should we call it pair? I kind of want to call it pair. Am I crazy? I like it. So here we do a symbol add. Okay, we advance, and then we see, are we going to have an argument list? If we do, we're going to add a new expression. Just a tiny bit of Lisp, tiny taste of pair. Add it to my pie. So we got the args, and then we say, okay, we're going to make a pair. It's gonna have to be pair. And what's gonna be the token for the pair? Would it be the symbol? Kind of weird, right? Should it be the symbol token? So every AST node points to a token, but maybe this one doesn't. Maybe it doesn't point to a token. What do we do for no tokens, by the way? Do we just do nothing? Let's just, for now, make it that. Talk. Probably empty tokens better. Okay, so now we have a pair. And we have a symbol. And we want to do pair add kid. Oh, sorry, tree add kid. Pair symbol. And then pair args. And then you return the pair. Do you only have unary functions? No, I have functions, like the parse argument list is gonna, for the function list, there's, you mean like named functions, or like obviously this is a binary. So for the numbers, I have prefix, so like 3 is a prefix operator, suffix and infix. And then for the functions, you can have multiple arguments. So argument list is recursive, so it does a call to parse expression list until it hits the right paren, and the expression list is just going to keep parsing recursively. So you can have f of whatever. So you can do f of sine of 3, cosine of sine of f of 3, which will go infinite, but that ought to work. Okay, so the args is a list though, so that's why it's okay for it to be like that. Okay, so then we get a pair. Should we see what that does? I'm gonna save this stuff off because this is like useful note taking. Notes. and then we're gonna clear the board. Are we gonna crash when I do this? Yeah, we are. Oh no. Oh, edit and continue does not support changes to, oh, come on, edit and continue. We used to be friends. It's upset because I changed the value of an enum. Okay. What is it saying? Value stack pop RHS. Do up. Who's this? Do operator. Let's just disable tests for now. I think it's probably running a test and crashing in the eval. Yeah, but I bet it's gonna like really get upset. Okay. Pair, there it is. We have a pair. And then if we have, yeah, so that, okay, so then we have z of 3 is a pair, z of 4, and f of x is x. Okay, definition. Pair, symbol, expression. Pair, symbol, x. Why is it pair, symbol, x? Oh, because I'm doing it regardless. Okay, that's a bug. Okay, so parser. If I get an argument list, then, so it's really like if args. Return the pair. Else return symbol. Right? Yes. Okay, so we have definition pair. Fair enough. It's a definition of a pair. That's kind of cool. So it's even unresolved during definition. Is that based or crazy? I don't know. Does that mean like definitions are going to be first class something something? We'll find out. Okay, and then we have a pair f of 3. Cool. Z of 4, definition, no problem. And then a pair z of 3. And that has an expression list. So far, so gravy. And it doesn't, okay, so then it doesn't think it's a sub-expression. So like this, it's going to think it's an expression list. So expression list should really be called parentheses, I guess, generically. And then it's a list. And you just, I think what the actual parse I want is like expression well, it's like parentheses. And then list, add 3, 3, 3. I think that's what I want. Because you could have 3 plus 3, 3, and that would be parentheses, statements, 3 plus 3, 3. Or I just add 3, 3. And that's useful because like when I parse a list, like the way list parsing works is kind of bananas. I don't know, maybe it's like Lisp, but lists are using the comma as an operator. So as part of like the token for, where is it? Token Elixir. So there's a comma, right? And so when you see comma, comma is the list. And it's, oh, maybe that's right. So maybe it's right. It's an expression list. How is it different from a statement list? So it just isn't, except for semicolons. So commas and semicolons in my parser are infix op types with a specific precedence. So if you look at the op precedence, expression list simply has a higher precedence than statement list. And so that is what makes like 3, because of that, something like 3 plus 3, 1 plus 8 parses as 2 statements because the precedence of, like that parses as 2 statements of 2 lists as opposed to a list of statements. See, expression list, and then between them is an implicit statement. So because of that, really, is this correct then? It's an expression list. It's correct. There's no real need for parentheses. Yeah, I think that's right. Because it notes, so it can work out what the parentheses contain. It can work out. So if I did this, it should be statement list. Unexpected token. And that's just because it doesn't want to be able to do it. Because statements can't be inside parens at the moment. Which is maybe not a good thing. Why can't they be inside? Unexpected chunk. Unexpected statement chunk. Oh, it's not quite at that. Oh, yeah, unexpected statement chunk. And that's because the statement list is coming through. Right paren. Expecting a prefix or atom. Let's make a note of that. Okay, but for now that's all right. So we have an expression list. And so that means we will see a pair now instead of a raw symbol, right? So now it's probably just I'm gonna go through a bunch of unknown. Where's like our run advance? Okay, if instruction types eval. Else if so we got two pairs. I assume maybe you're right. Unexpected body chunk. Yeah, you're right. So why do you think that's happening? Oh, because I probably reset something? That's a good observation. Because statements probably reset something? What do statements reset? Parse statement chunk. And there's a parse statement list. Yeah, it's just seeing alone. Yeah, I think you're right. I think that's a good insight. Because it parses the statement. I think what's happening is that it parses the statement up to the colon, right? Because that's what parse statement does. Parse statement will break on a semicolon. Yeah, I think you're going in the right direction. So I think parse statement breaks on a semicolon. And I don't currently care that there's no opening, there's no closing paren, which should be, but here it just does that. Oh no, it does, missing closing paren. Interesting. Well, how does it know that? Oh, interesting. Okay, because if it doesn't see a right paren after the expression. Interesting. So parse argument list somehow eats. I think it somehow eats the right paren. Oh no, we don't trigger the missing close paren. Maybe it is parsing it twice. I think what's happening is this parse statement just eats all of like f open paren 1 colon, and then it's like, cool, I got a statement. In fact, what does that do? Let's grab these things for testing after. I think I already had them. Okay, so like what does f of 1 comma 3 do? Unexpected statement. Okay, but what does that do? Missing closing paren. So I think you're right. It doesn't eat it. I think you're right. I think you're onto something. So where is the expression list? So here's what parses the expression list. Missing closing paren. Parse argument list. What's the difference between... Oh, okay. Parse argument list happens here. So it's actually calling parse argument list, not... And parse argument list says, okay, if the token is a left paren, advance past it. Okay. Parse the expression list, which when you go to parse expression list, calls parse statement. Okay. Which presumably just parses one colon. Because we're calling parse expression list, not parse statement list. Okay, but anyway, so we parse the expression list, we get up to here, 1, 3. Oh, so I bet it's the same as this. No. Huh. Okay. And then it says, so it gets the expression list. And then if talk type is right paren, which if it got to here, it wouldn't be right paren, clearly, right? Like if this was a bunch of 3s, right? Well, it doesn't matter, it's just a token. What am I thinking? So it would be 3. It should trigger this. Okay, so let's see. Parse expression list. Wow. There we go. Okay. L at. What? Oh, right. What? Hasn't been called yet. Okay, I think we might have to start earlier than that. Here. Okay. Symbol. So talk ought to be F. Yeah, talk is F, and it says, okay, parse argument list. Let's go. Parse in that argument list. Indentation is whatever. Okay. That's weird. Oh yeah, token type is left paren. Oh, L at, it's already advanced. That's the next token. Okay. So L talk is paren. Okay, so token's paren, and it's like advanced paren. Okay, cool. Token is now 1. Parse expression list. We now have a list. Parse the statement. Okay, so the statement parsed up to the semicolon. Oh, is that what? Okay. If the parsed returned a statement list, it's at the moment probably because there's a break after the very last member of the list, which creates an implicit statement list. But in the future, for one, okay, this is another such things, we might actually want to support this. So at the moment, instead of fixing that parse, let's just see if a single expression list. Oh, I see. And silently accept that as the actual parse. Interesting. So it sounds like it's basically, yeah, git blame for sure. Git blame, oh no, it's me. I'd actually want to support this. Okay, so if the parse returned a state, let's see, maybe this is an easy fix. So parse statement, and the parse type is a statement list. Okay, if it's a statement list, it's probably because there's a break, but in any case, it's actually this. So we got this guy, we got 1 colon. So at the moment, instead of fixing that first, let's just see if there's a single expression list. It's the first statement. Silently accept that as that. This is weird. This is a weird idea. Why would I do that? Okay. Okay, and then it just basically says unexpected statement chunk. Okay. And the talk is paren, which is weird. Why is it paren? It shouldn't be L talk here, right? Because that's, Well, what is LTalk at this point? Close paren. So it's, okay, so this is like a red herring because we've already advanced to the next token. So really it's actually parse.talk. Huh? Parse.talk. Token. Oh, get token. So if we do that, we will actually get the true error, which is unexpected statement chunk : which is, oh, right, because we got the whole statement list. Okay. So it actually ate the whole thing. So we're actually very close. If we just like let it ride. Because it's already going to be an expression list. Like if we just say, okay, cool, just take it, it'll just give us a statement list, right? Yeah. Pair, symbol F, expression list, statement list. So does that mean you can do like that? No. So if you do 3, 4, that's an expression list, and then you do that, it's a statement list. But what was the thing before? Why is that not a statement list? Yeah, it is. It's a statement list. That's right. Yeah, that's right. That's correct. But it's... this paren version ought to not be called state expression list, because the list is the thing inside. The list is not the parens, right? Because 3, 3 should be an expression list, but paren, 3 should be, you know, see, now parses as a sub expression, but it should just parse as parens. And then that would make it clear that pair is like F parens statement list or F parens expression list or some crazy version thereof. Right? Does that sound good? Because then you can have F of 3, 3, you know, 4, 4, 4, 3, and have crazy stuff like that. Expression list, sub expression. See, that should be another parens. So it should be parens list, parens list, parens statement list. Right? So parser needs a new thing called parens. I want to... And it's just because we don't know what parens is until we... bunch, banana bunch. 1, 2, 3, 4, banana bunch. I think I'll lose my mind if it's bananas. Is there like something that rhymes with parens? Or some kind of container? Is it a box? Is it a box? A box of pears? I think it's a box. Maybe it's a box, you guys. Could you parse parens as a statement list instead of introducing a new AST type for them. I mean, it certainly feels like it's a statement list, but I think the distinction is just this, is that it's this thing, right? Like this is a statement. Well, let's look at this. So F1:3 and F1:3, okay? So if we're gonna say, what is this parse gonna be? This is gonna be pair, symbol. So we're saying this is just gonna be a statement list, 1, 3, okay? And then this would then be a pair, symbol, statement list, and it would be expression list, 1, 3, like this. Is that right? Maybe you're right. Maybe it is just a statement list. I think you're right. I think my kind of like, I have a urge for symmetry, so I'm always like, but I think you're right. I think they're not the same thing. So let's see. Let's kick the tires on it. Okay, so what if we have this? What if I have these? Because originally I was going to parse these as a statement list, right? Because obviously these, you could imagine these are clearly a, braces, and then you have 1, 3. Then this would get parsed as a statement list for sure. But maybe you're right. Maybe it is just a statement list. And so the difference then, so maybe the reason it was because if you have f of x blah, right, that parses as definition f and then I had expression list and then statement list, okay, for the actual body. But now it's going to be definition pair symbol f statement list x statement list blah. That's much better actually, because it's pretty clear, right? You have a definition. The definition binding is the pair symbol to state, symbol plus statement list for args. That looks, so the definition looks just like a call. It's just like before. And then the statement list is out here, so we can detect it. This is a symbol definition. And then if we have, oh, maybe we can't tell. No, we can still tell, because if you had Z4, that would be a definition pair. I'm gonna start doing 2. Symbol Z statement list 4. And then there just wouldn't be anything else. Whereas before it was definition symbol symbol Z4, I think. And see, you could have 1, comma 3 being a statement list with 2 elements, and the elements being a comma expression. Yeah, that's right. If you did 1, you have, if you did 1, 2, you have parens, comma 1, 2. Yeah, that's what this looks like it's shaping up to be. That you have a statement list with 2 elements, each of them being an expression list. And I guess, comma expression is C's version for expression list. I'm actually not clear on the difference between statements and expressions, but if you do allow semicolons in parens, I think that's a good way to parse for it. Yeah. The difference between statements and expressions is that expressions evaluate into a number, and they can be operands, and statements cannot. But as we move closer to functions being like truly first class, I think that distinction gets really, 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 really blurry. And the one place where it's like still kind of understandable is like definitions are statements rather than expressions, because otherwise you have really bananas stuff like, 3 times f of, or like z is 4 plus 8. And then you're like, if this is an expression that returns 4, this is like kind of weird, right? And so that's kind of the distinction. But I'll admit that, like, well, before it was like the difference between f used to be a statement because it's a function, and f of 3 used to be an expression because you can do f. Oh god, what do we crash on? Oh, this thing. Okay. Hopefully I think it saves my file every keystroke except for the crash. Yeah. Are you saying 1, 2 is just a statement list and there's no parens box? What about 1 versus 1? Yeah. Yeah, I think what Bullfrog's suggesting is that parens 1 colon semicolon 2 is a statement list. There's no parens box around. The parens box would be the statement list box. What about 1 versus parens 1? What about it? You would have value versus, so if you have 1, that would just parse to that would just parse to number 1, and 1 would parse to statement list number 1. So that's a little weird, right? Because I think this is a good one, because I think this is what was guarding against some other behaviors. Because if you have like 1 plus 3 comma 4, that is weird, right? Because that's like add number statement list 3, 4. And before that wouldn't have worked, but now this will parse and then it will fail at sort of runtime or eval time, right? Maybe that's good. Maybe that's the right time. I think it's the right time. Yeah, because it feels like, I think I like Bullfrog's intuition that like, if we're gonna have a box, I don't think it's any different for parsing than a statement list. And so I think the difference is only in the interpretation. And so if the difference is in the interpretation, then it's not part of like the AST's distinction. It would probably be like evaluator notices something about that statement list that's not kosher for this usage. Or, but maybe another way of saying it is, maybe this is the olive branch, is that like, yes, it's a statement list practically, but maybe just like pair is this indeterminate thing. Maybe it does make more sense to call this add number parens 3, 4 until we figure out what it is. But the key is that parens accepts semicolons too, as opposed to rejects them. And then in a later pass, we look at parens, and parens is like, because if you had 1 plus 3 plus 4, you would get add number parens add 3, 4. And so in this case, parens has a single child, right? And if you had 1 plus 3 comma 4, you would have add number parens expression list 3, 4. And so then you can start to say, okay, add this parens can be labeled as expression list. This paren can be labeled as statement list. And then this parens is, this is a value. And then this one is a statement list. And so that's like a value, that happens as a post process after parsing. Or in fact, parse statement can return like how many statements it got, right? But really, again, it kind of comes back to this distinction that statement list of one statement is a valid argument. It's really just about the number of statements. Except in this case, 1 plus 3 comma 4 is kind of weird, right? Although, weirdly, people have been asking for vectors, and maybe that would work as a vector syntax. So really, it's up to eval what it accepts in the parens. Maybe it's just like during eval, we call parens, and parens does a bunch of stuff. And then add is like, hey, do you have like a single argument for me there? And parens was like, no, bro, I got like 16 arguments. And add is like, nah, that's crazy, man. That must have been a statement list or something. Can you err on semicolon in parens? Then parens are just always an expression list. Do you have a use case for multiple statements? Yeah, that's kind of what I'm getting around. Like right now, I do effectively error on a semicolon inside parens because I don't currently have a use for semicolons inside parens. But I do want for loops and things eventually, I think. I don't know if I'll do them that same way, but I'm just kind of like mentally trying to get my head around like where this started was up here. I was just testing random stuff. I think I was testing this stuff. And I was basically saying, okay, I've got this thing and it's making a pair of expression list. But I liked your idea that if it was just statement of expression list, then it's simpler, I think. Because what was causing the problem before? What was the bug where did we come from? Gotta unwind the stack. This thing or something? This auto work. We were having like a weird, it was really because we were getting a paren coming back. I forget the use case. Probably breaking out of parsing context. You want the expression list to parse to be aware. Yeah. Yeah, I think that's correct. But I don't remember why I wanted it. Is it just because I got sidetracked for wanting it to work for that? And because I was just looking at that function and I was like, why is this doing this? I guess it's because I want to, I think maybe the general feeling is that I want to defer this kind of stuff for later. Maybe that's what the idea was. Maybe this is okay enough for now. Okay. So is this what we want for now? I think it is. Pair, symbol, expression list. So that we know we can then change the pair to a multiply. And here we know we can change the pair to a function call. And here we have a definition, so we don't need to worry about it. And here we have a definition with a pair. And in this case, this is kind of weird because inside the definition, we didn't used to have a pair, but I guess we could just eat the pair in the definition and say, cool, we expect a pair, just go into it and treat it like normal. Right? I think that's right. So there's basically a couple of cases where we have pairs. And the question is, oh, but this, another symbol x. So it's like x times x. We lost the statement list. Here. Didn't we used to have a statement list? Did we used to have a statement list? Did that disappear as part of the pair? Let's check the eval. Eval definition. Determine definition type. Symbol express. Yeah, okay, no, it's all correct. If it's a symbol, if it's a single assign, it's a function. Otherwise, it's a variable. So all of this would have to change. So now we're like not parsing, anything. Everything's like an internal fault. Okay, let's grab this as our test case. And let's just mess with things. Let's just see how far we get. X is 3. Definition symbol 3. Cool. F of X is 3, 4. F of X is X squared. Okay. Definition pair symbol expression list. Okay. So that no longer works, right? F of 3. Internal fault. Good. Okay. So what we want to do is right now just peek inside the definition. But another option is to just lift the pair. So remove the pair. But then it's expecting 3 kids worth of definitions. So is that what it expects? I think not. I think it currently expects symbol and then expression list under it. I'm going to have a quick look at what we used to do real quick. So let's just stash. Stash. I just don't remember if we have a statement list in there or not before. Yeah, we had a statement list before. Right. And so when I made that pair thing, somehow we lost the statement list too. So let's save that real quick. So we lost that somewhere. Where's my unstash? Have a good night, Crayon. Thank you for your help. Yes, we lost the statement list, but I don't know where. It's interesting that the pair is what seems to have lost the statement list. How does that work? That's wild. Because I didn't change anything around the statement list. Right? If I do that, still not back. So it's something that I did with the pair. Let's just bring the old code back. The old code was just this, and this, and this. Oops. There's a statement list again. Wild. Okay, so that's interesting. So somehow doing this, the pair removed the statement list. Why is that? Is it because it's expecting a type symbol? I think so. But why does that matter? Definition. If type definition implicit operator is true. Aha. If op type is definition, and the expression type is symbol, and expression has a kid, function definitions are special in that they parse a nested statement list at a deeper indentation. Otherwise, parse the statement as this precedence. Okay, so when I did the pair, I screwed this up. So if it's a definition, and that's the LHS, function definitions. Oh, great. Okay. Interesting. Okay. So function definitions are definitions where the left-hand side is a symbol with a child, which in the new version would be a pair. And variable definitions don't have a pair because there's no parentheses. So actually, if it's a definition and expert type is pair, everything should work. And then we put our pairs back. Bajam. We have an expression list, statement list. Okay. Okay. And then X3 still works because it's the definition of a symbol. And so nothing fancy there. I like it. Pairs. Pairs are doing great. Okay. So now what we want is, I thought we would want to pass where we convert pairs based on the symbol table. But maybe we do that at eval time, because they're basically our indication that we have to do a lookup. So at eval time, determine definition type. So there's probably that needs to happen. So here we have an operator here. If it's a pair, what do we need to do when it's a pair? So I guess when it's just a pair node, we don't know if it's we no longer know it might be an operator. Or it might be a function call. So that's where that table comes in that we discussed earlier. This one. Pair table. Expression. So we need to look up the symbols to know what to do with it. For one, with a naked pair. But first we need to do the definition. So determine definition type, LHS, RHS, definition types on the left. Eval definition. Let's keep it simple. So we're going to have this. Must be coming in. Oh. LHS. RHS. No? Oh. Okay. Node. What's a node? Definition. Okay. LHS pair. Right. Pair F. Type pair, token F. Okay, fine. The token's misleading, but okay. Pair. So it's not the LHS. Oh, I guess it's saying we're defining a pair. Okay, fine. So if we define a pair, it's going to be a function. If we just define a symbol, it's going to be a variable node. Okay. Okay, LHS out. I guess now this is going to be okay, maybe. Yeah, okay. But we're going to have to treat LHS differently, depending on whether it's a function or not. Okay. Node kid sib statement X. Right, so that's the part that's wrong because oh no, that's right. It's just we're defining a pair now. Okay, RHS is correct. Okay, and then it's saying if LHS type is a symbol, otherwise it's a list of, okay. Okay, so now instead of if LHS has a kid, then it's a function. Okay, so now we really just need this. Else if LHS.type. This is actually the function. Params out LHS kid. So that's the parameters. If it's a symbol, now we want to like assert that there is no kid. And it's a variable. And LHS out feels like it ought to be F, right? Not the pair. But let's see first. Okay, if it's a variable, if it's a function, do we not care about params anymore? That's funny. So actually, we don't even care about params anymore. But LHS for functions is a pair. So it's really that, but that might be. Okay. Board. Ah, right. Right, it can't be because we need to know the parameter count. So we know it's a function. But now the function is now a pair. And then there's the params. Okay, so now like this whole thing is a change. So when I assert val function kid is the function symbol pair. The kid.sib is function params. Okay. That's right. Okay. And call function. Function kid sib. Function is the definition, right? Function kid sib. Okay, this is like function def. So actually the body is still should be the statement list. Function kid is a symbol. Function kid. Oh, this is the definition. Definition is the... Yeah, so this is the definition. This is the pair. Dot kid is the function symbol. Is the function params. That's got to be the expression list. So the params is this. Kid sib. Okay, that makes sense now. And then here, then the body remains kid sib. But the args are now kid sib. Because it's pair, function, sibling. Okay. Function. Okay. Now when we call a pair, we need to figure out if it's a function call. And then we know, well, by default, we need to know that we can just say pairs are function calls for now. Because they're no longer ever eval variables. And the function call is the node.kid. Unknown function f. Okay. Fine. Doesn't know the function. Okay. And that's because the lookup, probably the define and the bind, is not doing its job. Right? Because where's the function definition? Do definition, function. Make bind instruction. And before the LHS was the function symbol, and now the LHS is the pair. I see. So now we need to look up. When we look things up, we need to check potentially the pair. Now we have a bunch of pairs in there. So when we do lookup for a symbol, we need to look up pairs. Interesting. But that's let's look at this. How does this go? LHS is a pair F, so that's actually kind of good. Naut is a pair F, okay. So then, let's check this part. Symbol is F3, length 1. So actually it's just F, okay? Scope stack lookup, lookup. String, F. Symbol table lookup. How come we didn't? Okay. Huh. Why isn't that true? Make bind instruction. Okay, maybe the bind is not working. Probably doesn't know how to do the bind. Do bind. Right, okay. Bind is a bind, just binds values. So error checking, I think should just be done here. Okay, bind one value to one symbol. Yeah. So I guess this is like or node.type. And if it's a pair, I mean, this will just work, but eval function call. Okay. Where's my little... where's the other definition? This stuff. Okay. All these need to be replaced. Ugh. Okay. I guess the better... Well, I was going to say we could just have the things renamed and then assert on those. So basically like this. Are we going to use node name equals this. Then I can replace them. And then val function kid, node kid. Val, oh god, okay, so that's going to be params kid. Okay, because that's an expression list. Good. Node kid is the node coming in. So that's the function coming in. So this is also going to be a pair. This will have to be a pair. So whoever's calling an eval function call here has to pass the node, and it's going to have to be a pair. So here we're going to also have to do st args equals node kid. Okay. Param sib, arg sib, good. Okay. Function call, make eval instruction. Kid sib. Kid sib is the body, right? Kid sib is the body. Bind the args to the scope. Kid kid. Kid kid is the params. Okay. Eval all of the, that's going to be args again, right? Arg sib. Yeah. Okay. Same thing here. Args is actually this. Over here. Yeah, doing calculator stream.
Are you still going? How long is the stream?
I'm just programming. I'm just streaming it because people are interested.
Oh.
People come and go.
I am wondering if Kylie's having a bath.
Okay, so this is args. Same thing, but we're pushing it for the built-ins. And this is node get token. Too many arguments, too many arguments. Oh, this is for, oh, this is for, yeah, so this is also args. Not a function node. Oh. Right, because this lookup is the looked up function. And the arg, the node is the function name. So that's okay. I see. Called function. The call. It's called the call. So this is call get token. So now for pairs, is tnode call is equal to node kid. Node args is equal to node.kid.sib. Okay. And then all of this keep that. That's correct. That's the pair. Okay. And then the name is this. And the params is this. And then the body is the sibling of name. No? Yes? Yeah. Well, no, because... Oh, yeah, no, it's the definition of... It's the sib of the pair. Yep, that's right. It should be a statement list. Yeah. Number 9. Okay. Z is free. Z. Mother of God. Okay, so now Z of 3, not a function Z. Okay, so I think we're at least back where we started. But now all the tests are wrong because the parses will be wrong for all of them. Unless we express pairs as... Yes, all the tests are wrong. Oh well. So, but now here we have the option. We have the indeterminate pair, and we can make this a multiply if we want. We can now make this a multiply. That was a lot of work just to get to that point. But I think we need it anyway, because I think when I go to simplify things, it's going to be... I think we need this anyway. Because if I run the simplifier, Z should resolve to a 3. And so right now, it's like... basically want to do the symbol lookup and say if it's blah, 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 then it's multiply. Okay, so then how does this work? So now it's 3 sub expression 3. Okay, and that's because we allow for sub expressions. We say that's a sub expression. So, but really that bug, which is a bug, really ought to have just been like that. Probably could have just been parsed here. Because basically, if the current token isn't an op, let's try some implicit parses. If the current LHS would be a number and the next token is a symbol, that's an implicit multiply. Okay. If type is unknown, so that's the next one. And is expression expert type. So we have an expression. And the next token type is symbol. Right, so really we need to also eat if next type is paren. So we can kind of just test it here, interestingly. Like, what if we just do that? Right, because the symbol picks it up. So the actual fix was this one-liner for the bug, because the bug we set out to solve was this one, right? But the pair side quest is what is all the other stuff. Because now this works, right? There we go. All right. Well, that was a big detour. Could have just fixed it with that, but it was, I think I still want this to be the same. And so now I can do that. In fact, let's just finish that part. Because otherwise, okay, so here we just need to see, we have a pair now, symbol expression list. And so now we need to look up the thing, figure out if it's a function or a variable. And if it's a variable, place it as a multiply. Otherwise, function call. Okay, so we could do that. Function call. First thing it does is does a lookup. Okay, so we can just grab that. A little bit inefficient, but let's just do it. Okay, so take the node. Val. And val type is function. So like if we look it up, otherwise unknown symbol, right? Message type unknown. Do we have like unknown symbol? Unknown function, unknown variable. So it's really like now we don't really know unknown symbol. Now we may just not know. And then it's like if val.type function, then we call that. Else we have to do something funky, which is eval operator. Which is a little bit crazy. Because if it's a binary, so we kind of like have to invent a node. This is, I mean, on the fly, we can just change it to a multiply. Make op instruction. Because it's making it, right? And then eval instruction, kid, right? So we can do this. But make op instruction is a little weird, right? Like eval op, eval operator, and this do operator. Like here is where it actually gets the node type, right? Where's the node type come through? Yeah, so here, this type, unfortunately. So if this was operator type, then we wouldn't have to do this. Okay. Can I fudge it? Kind of sketchy. Not tokens, types, I guess. Types. Would it be crazy to parse pair as multiply and then just define function times expression list as a function application? That's bananas. Just like, that took me a second. Oh, wow. That's wild. That's really wild. Uh, I can't tell if that's like galaxy brain or hack. Because like multiplication has this sort of like almost matrix operation connotation. Like multiplying matrices is like applying the matrix, and so is multiplying a function by a vector. Like if you multiply a matrix by a vector, which is kind of like an expression list, it's kind of like applying a matrix to the vector. And so what if like multiplying a function by what looks to be like a vector, which is an expression list, evaluates the function on that input? That's really crazy. I wonder if that has any connection to the actual notation, or if that's just a really crazy galaxy brain. I'm gonna have to sleep on that. I'm gonna take that comment and just like write it in here. The bullfrog says, what if f times x per list is a function call? Mind blown. I will sleep on that. I will sleep on that. Okay. This is pretty gross. Is it operator mole? I forget what it is. What's the actual name? I'm not supposed to be editing the like operator at this stage. It's pretty gross, not gonna lie. I would much rather that I was able to just do an operator eval here, but I think that should work. I guess, yeah, leave a comment. Then again, be anyway. Let's make node types. Is that gonna work? Let's see. Is this crazy? Thanks for sticking it out, Bullfrog. I didn't even know people were still here. Okay. Works. I don't know if this is a good thing or a bad thing, because what? Was it? Was it? It? I was gonna say that then you could do pi times whatever, but we just crashed out. Aborted for what reason? Eval 357. Did we just crash out as I was typing? 357. What's this stuff again? What's this freaking assert? Oh. Why is that? Um. Yeah, okay, because it's unknown symbol. But why is it saying unknown symbol? Why is it still doing the operator? How does it get to do operator? Is that a mistake? Must be a mistake on my part. Are we still getting into here? No. How does it get to do operator? How is it getting to here? Subtraction. So subtraction must have a pair? Oh, there's just no value. Why did he get pushed then? Eval operator. If binary. Oh, I see. What's the parse? Let's see. Definition, subtraction, number pair. I see. So subtraction, number pair, and then pair fails to push anything. Okay, so in the case that pair needs to push a nil. So in the event that you eval something, you can't just add error, you have to eval variable. And if you fail the lookup, you need to push a nil. So if we have a push value rec, then we need to add a nil value. And how do we know if we have a push value rec? If the instruction has a push value. Okay, so we do if inst.push value, we need to push a nil value. Basically, if we fail to resolve anything, we got to push a nil so that the operators can be happy. Okay, so then it's just unknown symbol. And unknown symbol, and we can give it a toke. Node.token, like that. Unknown symbol p. Okay, so then if you say pi, unknown symbol pi, why? Pi should look up. Oh god, because we need to. Because we need to also look up. You have to look up the built-in constant as well. Should we just eval variable? Oh, oh no, we already do the eval variable, right? Right, so it's like it looks it up, can't find it as a simple. If it's a function, then it evals it as a mul. God, this is gross. Okay, so then we have to do else if eval lookup built-in function, lookup built-in constant. Oh god, but then we have to also look up the built-in functions. God damn. Oh, geez. Gross. Gross. Because eval function call does built-in function. So it's basically saying like, we need like, yeah. Annoying. Okay. You have to do this too. Okay. So we need to abstract that out because it's just kind of gross. So we need to say, is it, if it's a function or a variable. Yeah, that's annoying. Okay. Not done yet. Lookup symbol type. This is kind of expensive for no reason, but we're just gonna have to roll with it for now. Okay. So here's how it's gonna work. Gonna check this. AST node. I'm gonna look it up. We need cal. It's a function. Return value type. Well, if we looked it up, just return value type. Okay. Else. Do we have a nil value type? Probably, right? Yeah, okay. Return value type nil. Otherwise, okay. So that's like if nothing gets found. Okay, and then so now we need to also look up the built-in constant. That's going to be the built-in function, built-in constant. Throw away the result. It's so ugly. So if it's a built-in constant or a built-in function, where's built-in function? Throw that away too. Return type function. Okay, so basically a bunch of lookups for no reason other than just to determine the type, and then we're gonna have to do the lookups again when we do the eval. So really the proper thing would have been to look up the symbol, store the value type and whatever else you find, and then pass that down. But instead, we're gonna say type lookup symbol type cal inst node and then we just do this. If type is that. If type is function. Else if type value type. Variable. Yeah, if we looked it up and it's a variable on the left-hand side of the pair, then we change the pair to a mole. And then otherwise, we push a nil value if we need to. God damn. Pi, there it is. Okay, and sign still works because it's a function. Sweet. Wow. Okay, this was a thing. This was a thing. So that's the word. Oh, no, what? What? What's going on? Why is that not working? Number. Oh, it thinks it's a number. Yeah, one sec. Okay, so it's not, it's number or, okay, now I have to double check. Number, oh God, it could be a string. Let's just pretend that strings don't exist and that we don't want to multiply by strings. So x evals to a number. That's kind of weird. I guess because it sets the value. What's in the symbol table for x is not x, it's the value of x. But what's in the symbol table for f is f. Well, no, I guess a function is a body. So really it's like eval body. The body is in the value. Interesting. I mean, it's probably never a variable then. Hmm. 56. 56x, right? Because it's x times 3. There it is. Fault. Why is that a fault? I guess that's just an error, right? Empty expression list. I don't know. Is an empty expression just an error? Just nil, right? But times, so pair says its symbol. So it evals it, and then it evals the expression list, and then expression list becomes part of a multiply. We just haven't had to handle. So it would be the same as like 3 times that, right? Or 3 times 1, 3. Whoa, what? That's a weird output. That's like really bonkers, actually, that it's parsing 3 times sub-expression expression list. That's interesting that that even works. That shouldn't work. Wild. That shouldn't work yet. Geez, a lot to be done to support this stuff. It's a crazy side quest. Okay. What should that give, though? I guess that should just give error empty expression. But I guess we're getting the internal fault from the operator, because we're getting a nil or something. Where's the do operator? this stuff, right? RHS is nil. Probably, yeah. There's nothing on the RHS saying fault. But it's not really a fault. It's basically saying the right-hand side of the operator is nil. So is that the same as like A? No, because the symbol would resolve to a nil, so it would get something. That's too few arguments to function call. What? What is that? Too few arguments to function call. How is that happening? Which function are we evaluating? Oh, it's evaluating a built-in? No. Oh, eval app here. Okay, okay. So that is a thing. That's a stupid name for a thing. Yeah, that's a stupid too few arguments. Yeah, it should be too few operands. And it should give the node. Too few operands. Yeah, 4. Yeah. Okay. Okay. So that's nil. That one is, it's still an internal fault. And that's because when we actually do the eval, there's nothing on the value. And that's because eval operator here must have pushed something wacky. Okay, so what's it pushing? So is it binary? Yes. Do we have two things? Yes, I see. So it pushes stuff. It made it a multiply, but it's a multiply with an empty list. Okay. It makes the instructions to eval those things. Okay, and then we actually get inside and it's an eval. And it's going to be an expression list. There it is. Kids nil, and it doesn't have any kids. So it basically pushes all the kids. Okay, so we have to say if kid do that, else this. So an empty list evaluates to a nil. Jesus. Okay. All right. Well, I think that's gonna be it for tonight, because I don't think I can actually ship this fully without running all the tests. But if I run all the tests, they are almost certainly gonna fail. I mean, they will for sure fail because all the parse, yeah. Oh, wow. Oh man, it's like close. It's close enough that I could. Oh, these freak me out. I shouldn't have looked at this. If the indentation tests are fucked, I'd be like so sad. Oh, should I look? Should I look? I'm scared. If I tug on this and the indentation rules are busted, like most of them, you can see the parse is just like there's a double F here because now pairs parse as like kind of like a name because it's like a nested name. So I bet most of them should work. But like, should I just unwrap the pairs during the tests and see if that makes it work? Oh, I'm scared to look. Okay. Indentation. Indentation 01. I'm looking. I'm scared. Okay. It's the indentation test. Output 6. Output 6. Okay. Thank God. At least that's good. At least the output's right. I'm just going to run them manually. Let's see what the worst ones are. Okay, like this one. Oh, lordy. All right. Let's see. Does this pass? 6. Oh, thank God. Okay, I can go to sleep tonight. Okay, so it's just gonna be that I need to update some of these tests because they now output this weird pair. Yeah. Implicit semicolon. Oh God, I'm pushing my luck here. Semicolons, implicit semicolons are the more likely ones to not work, right? Because I changed the semicolon rules. Oh God, okay. Okay, we're doing it. Oh, really rolling the dice here. Okay, -3, 3. Okay, okay, good, good, good. Implicit semicolon. See, there's these weird 1, 2, 1, 2. Oh, thank God. Okay. Okay. List rules. List 01. 3, 4, 3, 4. Okay. Well, this is a good sign. Maybe I can ship it. Oh, should I just ship it? Multi-ret. These are all passing, guys. Okay, so, I mean, at least they're manually passing, and I'm sure these are probably going to be passing if I have to pass them. So I can just, okay, so one easy thing I can do is I can change the way we parse. So like the parse printer, print AST parse. Okay, so right now it doesn't know what a pair is. So So it's just saying everyone else is a binary operator for now. Right, and it's just parsing like this. Okay, so if I just say else if n dot type ast node type pair. Okay, but we don't anymore know whether it's a function call or not. So but we don't have any tests that test the implicitness of it. So it should just be as if you put them one after the other. Is that right? Because like for the function, like what if I just do the kid and the kid sib? Because the kid sib's going to be an expression. Lols. All tests green. Well, that's cool. Okay, so pair is at least, you know, sort of considered to be just as if it's one thing after the other. Slightly dodgy. Pair isn't really just the two kids, but for sake of consistency with old parsing tests, at least we know the results pass, which gives me a lot of confidence to actually ship it. I think I'm gonna ship it. I think we did it. We did it, chat. So, bug solved. Big quest. And we don't run out of focus when we're out of focus. So I'd call that a pretty good day. Thank y'alls. Now it's the end for reals. See you next time.